trying to pave the way to get to Mars with humans, and that's why we called it the Baker Project, because Miss Baker, the squirrel monkey, paved the way for humans to go to space.
And so we're paving the way to go to Mars.
And we're going to assemble all the different parts in space that are going to be built in future years. And it's going to go to Mars and come back. And if that is successful, then we will do it with a manned spaceship.
Our team's part was to make the AES
atmospheric escape stage.
Yes, and we made the S-band transmitter docking stage. We made an ohms engine, solar panels, like what most satellites have, and
it's gonna deploy from the orbiter payload bay, and when they get high enough into space, they're gonna deploy it, our astronauts, and it will go up until it reaches a safe distance away from the orbiter, and it will deploy the cowl that we have on there, which protects the AES. If anything like space junk or something were to happen to it, it would protect it, and we will jettison it and deploy our S-band and
solar panels.
Our solar panels, and we will boost it out of the way from the cowl, and the cowl will eventually
burn up in the Earth's, re-entering the Earth's atmosphere.
And burn up.
Well, after we jettison the protective cowl, we use these called the RCS engines, and it helps us deorbit this, so and then it slows down, and then it will re-enter the Earth's atmosphere and burn up. The reason we have to deorbit the protective cowl is because if we do not, it will just be space junk, and then it could damage other things like other satellites, space shuttles, or the AES, what it is supposed to be protecting.
We call it the atmospheric escape stage because we're trying to get it out. It's already out of the atmosphere, and
we are trying to get it farther out of the atmosphere so we can drop our nuke bees.
Yeah, and we're using hypergolic fuels to get it further away from the atmosphere so we can drop the nuke bees, because the nuke bees are nuclear and we don't want that getting into our atmosphere.
And polluting
our air and stuff.
And
it could kill us if it
rate
got
the
in our
radiation.
atmosphere and stuff.
So we gonna get out of a high enough safe distance so we can drop it and it won't pollute anywhere near the atmosphere. So it would be safe and no one gets hurt.
We're looking at the AES deployment time. It is 7 hours and 15 minutes behind the mission elapsed time. It's counting down to when we deploy the AES, which is the first part of the Baker Project, on May 8th for STS-16.
The protector cowl protects the AES from when the shuttle lifts off, and the ET and the SRB are shaking and if the protective cowl was not there, the solar panels and the S-band transmitter receiver would be damaged. And without the solar panels, we would not be able to charge up, so that we would have enough power.
Well, for our backup project, we use nuclear post-propulsion. And, okay, imagine this. The ET, it's this massive thing on the orbiter, well, space shuttle, and it is probably, I think, it uses the most fuel, and with the nuclear post-propulsion, you don't have to use as much, because the ET, it's this massive amount of fuel, and you lose that in 8 minutes. But with nuclear post-propulsion, you can use way less than that and just keep going for months and months and months.
At some point,
yeah.
it was when we had to build it. That was
because we had so many people with so many decisions. It was a big, like, I don't know, but we eventually problem solved, figured it out, and we used everybody's ideas. So, and we all got it working. So,
programming was pretty hard, but it was really hard building it because you had to know what things to do.
Yeah.
And we would teach each other different things that we learned when we would practice on it. And we would try to make the different things at different angles, and we would have to, we would do different things that we thought that we couldn't do, but then when we put our minds to it, we did it.
And then we had to put this into one program and then transfer it to another and another.
Like, the main programs that we used was Alice and 3ds Max Autodesk.
Yeah,
and
that too.
We don't know what can happen in life, so doing something like this is it's like seeing the future. Like, maybe NASA might call you up and say, "Oh, we need help making a payload to get us a man to Mars," and then you could say, "Yeah, I had some experience in that."
Yeah.
This is my first year ever doing something this cool, and and I'm still at a young age, so I still have a lot to go. And doing this inspired me to do things that I didn't think I could do. So.
Shutdown sequence. Copy that. Battery 128.1 and set one NiCad battery 2 is 27.5. Copy that. Set one oxidizer pressure 431.8 and set one fuel pressure is 433.2. Has been executed and that the orbiter is now in correct attitude for the Sat-1 deployment. Copy that. Flight advise the crew that the Sat-1 deployment is in 60 seconds. Copy that.